Hello. In this session, we are solving 2019 HSC Extension 2, Question 16, Part B. Pz is equal to z to the 4 minus 2kz cubed plus 2k squared z squared plus mz plus 1, where k and m are real numbers. The roots of Pz are alpha, alpha bar, beta, and beta bar. It is given that modulus of alpha is 1 and modulus of beta also is 1. Show that real part of alpha squared plus real part of beta squared equal to 1. Let alpha be cis theta. You know that each complex number can be written as modulus times cis of its argument. Here modulus is 1, so that's why we can just drop it. So alpha becomes cis theta, and similarly for beta is cis gamma, where gamma is the argument of beta. All right, using the sum of the roots, we have cis theta and cis minus theta, that is alpha bar, plus cis gamma, that's beta, plus cis minus gamma, that is beta bar, which is conjugate of beta, equal to minus b on a, which is minus 2k on 1, which is 2k. Here we've got two numbers which are conjugates, so their imaginary parts cancel, and we get the two equal real parts. So we get 2 cos theta. The same for this one, 2 cos gamma equal to 2k. Then dividing both sides by 2, we get cos theta plus cos gamma equal to k. That is for the sum of the roots. Let's see what we get if we arrange two of the roots together. That's going to be cis theta times cis minus theta, then plus cis theta times cis gamma, then plus cis theta times cis minus gamma, plus cis minus theta times cis gamma, and cis minus theta times cis minus gamma, and plus cis gamma times cis minus gamma. Alright, these are all the combinations we get for when we arrange two of the roots together. And that will be equal to this divided by 1. So we are going to have 2k squared. Cis theta times cis minus theta becomes cis theta minus theta, which is cis 0. When you timesing two complex numbers, you add their arguments and times their modulus. So just becomes cis 0 is 1. So that becomes 1. That becomes cis, here I'm adding the arguments, theta plus gamma, cis theta plus gamma, plus cis theta minus gamma plus cis minus theta plus gamma plus cis minus theta minus gamma and cis, that is cis 0. I can write as cis 0 or I can just write it as 1. So this becomes just and so we had minus theta plus gamma, then cis minus theta minus gamma, and these two became 1 equal to 2k squared, 2k squared. And now if we test 1 and 1, we take it to the other side, and that becomes 2k squared minus 2. But before that, as you can see, theta plus gamma and minus theta minus gamma are conjugate of each other because they are two opposite angles. So we are going to have 2 times the real parts. So the imaginary parts cancel out. So 2 cos theta plus gamma. That is for these two. Similarly, these two are conjugate of each other, so we are going to have 2 times the real part of them. So, and this 1 and 1 is 2, we take it to the other side, we get 2k squared minus 2. And dividing both sides by 2, we get cos theta plus gamma plus cos theta minus gamma equal to k squared minus 1. Now if we expand this, that's going to be cos theta cos gamma minus sin theta sin gamma. And this is going to be cos theta cos gamma plus sin theta sin gamma. And that will give us cos cos theta cos gamma and cos theta cos gamma. If I maybe just expand it, cos theta cos gamma minus sin theta sin gamma plus cos theta cos gamma plus sin theta sin gamma sin gamma is equal to k squared minus 1, and these two cancel each other out, and we end up with 2 cos theta cos gamma is equal to k squared minus 1. Alright, now I'm going to use this and square both sides of that. So let's call this 1. So square both sides of 1. That will give me cos squared theta plus cos squared gamma plus 2 cos theta cos gamma equal to k squared. And 2 cos theta cos gamma, which I have here, is equal to k squared minus 1. So I'm going to use 2 in that. So use 2. If I use 2 here, I'm going to get cos squared theta plus cos squared gamma plus k squared minus 1 is going to replace 2 cos theta. K squared minus 1 equal to k squared. Then k squared and k squared cancel out from both sides, and 1 goes to the other side, and we get cos squared theta plus cos squared gamma is equal to 1. But cos theta and cos gamma are the real parts of alpha and beta. So we proved we prove what they asked us to be proved. Thank you for your attention.